So this lesson is about two things, actually. We're converting between two types of ways to measure angles. Now, in science or in any other things, there are many ways to measure something like distance, right? You could measure distance in centimeters, or you could measure distance in inches. You could measure longer distances in miles, or you could measure them in kilometers, right? There's different measuring systems that we use. In math, there are two different ways to measure angles. The way that you've been learning through all your math career is degrees, right? 45 degrees, 180 degrees, 90 degrees. However, there is another way to measure angles, and that's what we're covering today. And that is called radians. So instead of degrees, it's called radians. Now, what is a radian, right? What is the measure of 1 radian? Well, the radian is when, and you can see here in the picture, it is the angle that is made when the radius, see this R here, is the same as the arc length. So we're actually going to call this the arc length. If you remember from geometry, that one section of the circle is called an arc length. So let's say you have a radius of 5. If this arc length is also 5, then the angle made with the arc length and the radius is 1 radian. Okay? So actually here, a radian is actually equal to the arc length divided by the radius. Okay? And so 1 radian, remember, how do we, if we divide, remember that like 5 divided by 5 is 1, 10 divided by 10 is 1. So that means 1 radian is when arc length and the radius are the same, because this number would be the same, it would divide to 1. So 1 radian is when the radius equals the arc length. Now, okay, that's fine, but how many radians is in, how can we convert between radians and degrees, right? Well, I know that a full circle is 360 degrees, right? So if we did a full circle, like let's say I started here and I went all the way around until I went here, then the arc length is actually the circumference of the circle. And so if you remember from geometry, the circumference is 2 pi r. So how many radians are around a circle? Well, let's use this definition here. A radian is the arc length divided by the radius. If we went the whole circle, the arc length is just the circumference. So how many radians are in a whole circle? The arc length is 2 pi r, and I divide by the radius. The r's cancel. And so in one full circle, there are 2 pi radians.
Mr.
Yeah.
Do you want us to do that calculation, or do you just want us to put 2 pi?
2 pi, yeah. That's a very good question, Tony. When we do radians, a lot of the times they will have pi in there. You will never multiply the pi out, but Tony is right. 2 pi radians does mean around like 2 times 3.14. It ends up being something like 6.28. But in terms of trig, we always leave the pi in there. Okay? That's a very good question, Tony. So there are 2 pi radians in 360 degrees. So remember how I told you that you have stuff like inches and centimeters, right? And if you look it up, I think it's like 2.54 centimeters is 1 inch, right? That's just the same thing that's happening here. 360 degrees is the same as 2 pi radians. They mean the same thing, and that's 1 full circle. So 1 full circle is 360 degrees, but it's also 2 pi radians. Okay, look at the next question. How many radians is 180? Well, think about this. If this is 360, 180 is just half the circle, right? So if 2 pi radians is the full circle, then we just cut this in half. Well, how do we cut 2 pi in half? Well, think about it like this. If I have 2 pi and I cut it in half, that means I divide by 2.
Sure. Wouldn't it just be 1 pi radius?
Yes, very good. The 2's will cancel. And so how many radians is 180? So it's just pi radians, or 1 pi. But you know, a lot of times we do not put the 1 in front. But yes, it's just pi radians. That's it, right? If 2 pi is 360, then 180 is just 1 pi radians. And now let's think about this. How many radians is 90? Well, 90 is just half of 180, right? And so if I divide pi by 2, we could just leave it as a fraction. And this is pi over 2 radians. Okay, we'll get to the 45 and the 30 a little later, but I kind of want to show you, and we're just going to reinforce the concept. I think a lot of you kind of understand what's happening here, but let's actually look at, we're going to use fraction bars to discover more about radians. This is super important. 180 degrees is pi radians. And don't worry about the fraction bars if this gets a little cumbersome for you. Later on, we'll develop a technique to easily convert between degrees and radians. But I kind of want to show you something here. Remember that pi is 180 degrees. So if you remember from middle school, when we did fraction bars, right? This would be 0, this would be 1, and then this would be, right, we cut it into 2 pieces. Here, we cut into 3 pieces, so this would be 0, 1/3, 2/3, and then 1, right? So it's the same way it works with degrees and radians. If I was...
How did you get the radius? How many radiuses for 90 degrees?
So 90 is half of 180. So what's half of pi? You just divide it by 2, pi over 2.
Okay.
Okay. Now, so let's think about it this way, and I'm going to show you another way how we get the pi over 2 radians. It's here. So actually, Noelia, actually that question leads into this. I know that half of 180 is 90. And then so if 180 is pi, this is 1 whole, right? So if I divide pi into 2 pieces, this is pi over 2, okay? Because it's the same as 1/2, right? If this is 1, I divide it by 2 to get 1/2. If this is pi, I divide it by 2 to get pi over 2. Now, same thing happens here. What if I divide it into 3 sections? Well, 180 divided by 3 is 60. And then so if I add another 60, this would be 120. So the same thing that happens with the fraction bar, if I divide 1 by 3, I get 1/3. If I divide pi by 3, I get pi over 3. So 60 degrees and pi over 3 are the same thing. And then if this is 1/3, this would be 2/3 here. But now we're just going to include the pi. So it's 2 pi over 3. So if I'm just going to show you another thing here. So now we cut it into 4 pieces. So this would be 1/4. This would be 2/4. But what does 2/4 reduce to? This is just 1/2, right? And then this would be 3/4. So the same way we did the fraction bar, if this is 180, if I cut 180 divided by 4, you could just use your calculator for that. You would get this as 45. And then if we just keep adding 45, we get 90 and 135. So same thing here. If I cut it into 4 pieces, it's by fourths, right? So if I cut pi into pieces, it's also going to be in fourths. So this would be pi over 4. 90 degrees is 2 pi over 4, but look up here, we already did that and it was reduced. This is pi over 2. And then the 135 is 3 pi over 4. I'm just comparing it to what I did here, right? So,
Mister,
yeah.
do you want us to use this information, like how 45 is pi over 4, to answer the first 2 at the top?
Yes. So right here, how many radians is 45 degrees? That's pi over 4.
Pi.
Okay. And then how many radians is 30? We're actually going to do that right now. Because here, if I cut this into 6 pieces, this is 1/6. Okay, so this is 2/6, but 2/6 reduces to 1/3. This is 3/6, so it reduces to 1/2. 4/6 reduces to 2/3, and then this is 5/6, and then 1. So actually, the only 2 new ones on this bar are actually this one and this one. All of these we've already done in the previous fraction bars, right? So let's say this is 180, and I cut it into 6. So this would be 30. And if we go by 30, this is pretty simple. 60, 90, 120, and 150. And like I said, the green ones I circled are the only new ones because I already have 60, right, from up here. I already have 90, and I already have 120. So let's just fill them out because we already know these, that this is pi over 3. This 90 is pi over 2, and 120 is 2 pi over 3. But now the new ones, I'm dividing by 6. So I'm just going to use these fractions here, and this would be pi over 6, and 150 is just 5 pi over 6. Okay. And then so I could go ahead and answer the last question on the top, that this is pi over 6 radians. Okay, now this is fine and to understand the concept, but if you're going to actually convert between degrees and radians, it's kind of tedious. You don't want to be creating fraction bars, especially when you have something like 7 pi over 18, right? You don't want to know, oh, how many degrees is that? I have to cut it into 18 pieces, multiply by 7, right? But so we're going to do a very simple way to convert between degrees and radians. And we're going to go through that right now. And this is what you're going to be doing on your homework. We're actually going to skip all of this stuff because this would work better if I was in a class with you and just show you this simple shortcut. So if I want to convert from degrees to radians, all I have to do is just multiply by pi over 180. Now, why do I multiply by pi over 180? What's special about that is because, okay, if you don't have that yet, I'm gonna come back down to it in a bit. Remember what in the very beginning, I told you that this is really important. I circled it. 180 degrees is pi radians. So remember from chemistry how you need a conversion factor? This is our conversion factor. 180 is equivalent to pi. So to go from degrees to radians, our conversion factor is multiplying by pi over 180. And let me show you how it works. It's actually pretty simple. So let's say I want to convert, and this is what your homework is going to look like. I want to convert these into radians. So I have 60 degrees. So what I'm going to do is I'm just going to multiply 60, and I'm going to multiply it by pi over 180. Now we could just put a 1 over the 60. And so now I have this. I'm multiplying two fractions. And so all I need to do, oh, that's step 1. And in step 2, you always need to simplify. So we're going to simplify, and you see that I have a 60 on top and 180 on the bottom. So all I'm going to do is I'm going to simplify this, and then whatever I'm left with is the radian measure. So let's see how this is done. They're kind of big numbers, 60 and 180. But remember, in math, if they both end in a 0, they could both be divided by 10. I didn't kick Tony out, Naya. And I do not see him on trying to get back in. Okay, give me a second. Okay, tell him to check his email and try to get back on that link. Okay. Okay, so everyone else, let's go back to this. So 60 times pi over 180. So remember, they both end in a 0. So that means I could divide by 10. And if I divide 60 by 10, it's just 6. And if I divide 180 by 10, it's just 18, right? You just remove the 0. Now I can simplify this further. I could simplify by 6. 6 goes into 6 one time. 6 goes into 18 3 times. And so what am I left with? My final answer in radians. 1 times pi on the top is just pi. And then on the bottom, it's just 1 times 3. So 60 degrees is pi over 3 radians. Okay. Okay, so Tony, you just missed the first problem, but Tony, you missed the first problem, but I'm going to go over this process again.
Okay.
If I'm converting from degrees to radians, the simple thing to do is just to multiply by pi over 180 and then just to simplify. So look at letter A for 60. I did 60, I multiplied by pi over 180, and then I just simplified. So how does that work? I'm going to show you again here. I do 135, and I multiply by pi over 180. I could just put a 1 over 135 over 1. Now I just simplify this. If I have 135 and I have 180, one ends in a 5, one ends in a 0, so I know for sure I could simplify by 5, right? So you just use a calculator and do 135 divided by 5. So this is 27. And then 180 divided by 5 is 36. Now I could simplify this further. By the way, when you do radians, it does have to be simplified all the way. So you know how sometimes people ask, can we just leave it as is? No. For radians, always simplify it. So 27 and 36, the biggest number that can go into them is 9. 9 goes into 27 3 times. 9 goes into 36 4 times. And then now I can't simplify any further. So 135 degrees in radians, on the top it's just 3 and pi. And then on the bottom I have 4. So this is 3 pi over 4 radians. Okay. So go ahead and try C and D on your own.
Mister, how'd you get the 1?
Well, you're multiplying by fractions. So if you have a whole number, you always put it over 1, right?
Is it possible to have a decimal?
Well, these are all decimals, but you always leave them as fractions. Like 3 over 4 is a decimal, but you don't divide them. Are you talking about letter C? Like Nobelia, are you trying to do letter C?
I was looking at letter B and I was saying under the 135 there was a 1.
No, no. What are you talking about with the decimal?
Oh, because I was wondering, you said if since they were all whole, you were dividing by 1. What if the number was a decimal?
Which number?
The 135.
Well, then you probably would not do it. You would actually multiply it out to find radians, and the radians would be some kind of decimal number. But we're not doing that.
Okay.
But I want you all to try C and D. Okay, so letter C. Once again, I have 210, and I multiply by pi over 180. Once again, I put a 1 underneath here. Now, This one is simple because they both end in a 0. When they both end in a 0, you could divide by 10, which means just removing the last 0. So this is 21, and this is 18. And then now I just simplify 21 and 18. I could divide by 3. 21 divided by 3 is 7. 18 divided by 3 is 6. So you see that this is really just, it's mostly a simplifying fractions exercise. So here, the top, I'm just left with 7 pi over 6. And so that is my answer. Okay, and then the last one, if I'm converting to radians, 300, and I multiply it by pi over 180. Once again, the good thing about this one, they both end in zeros. When they both end in zeros, you could just remove the last 0. This is 30, and this is 18. And now the biggest number that can go into 30 and 18 is 6. So 6 goes into 30 5 times. 6 goes into 18 3 times. And so if I convert this to radians, it's 5 pi over 3. Okay, before we move on, any questions on how to convert degrees to radians? Because the next thing is we're going to convert the other way, radians to degrees.
Mister.
Yeah.
You leave it as an improper fraction though?
Yes.
Okay.
Okay, so that's the method from degrees to radians. Now we're going to work backwards. Just like in chemistry, if you go from inches to centimeters and if you go from centimeters to inches, you still use the same conversion unit, you just flip them. So, once again, this would be cool to do in class, but we're not in class. So, simple. If I want to go from radians to degrees, right? That's degrees. I multiply by 180 over pi. So you see how here on the top, and I'll go back down so you could copy it, but degrees to radians is multiplying by pi over 180. Okay? If I want to go from radians to degrees, I just flip it, and now it's 180 over pi.
So you want us to skip that part on?
Yeah, all of this stuff. Yeah, forget all that. Let's forget about this. Okay. Here's just the shortcut that you are going to need to know. Right here. Multiply by 180 over pi. So now, actually, I think this one's much easier than the other one. And here's why. So let's look at pi over 4. What I'm going to do is I'm just going to multiply pi over 4 times 180 over pi. And now all I do here is I see that the pi's will cancel. And all I do now is I have 180 on top and 4 on the bottom. So I'm just going to use my calculator and do 180 divided by 4. And so pi over 4 is the same thing as 45 degrees. This is just a bunch of calculator work. So if you could use your calculator right now and work this one with me. So 11 pi over 6, I multiply it by 180 over pi. So once again, what happens here? The pi's cancel. And now on the top, I have an 11 and a 180. So in your calculator, just multiply 11 times 180 and then you have a 6 on the bottom, so it's 11 times 180 divided by 6. And you'll get that this is 330 degrees. Okay, so go ahead and very quickly do C and D.
Mister, will there be homework problems like this?
Yes.
All right.
But any questions on this, Tony, on this process?
No.
Okay, cool.
You do know that C and D are the same thing.
Oh yeah, sorry. We were supposed to change D. D, make this 3 pi over 2. Thank you. I changed it in period 1, but I forgot. Okay, so let's go ahead and see our answers here. So 4 pi over 3, and I multiply by 180 over pi. By the way, you should know, you shouldn't get really confused over which one I multiply by pi over 180 and which one I multiply by 180 over pi, because I know going from radians to degrees, I need the pi's to cancel. So that's why pi has to be on the bottom. So it's 180 over pi. Whereas if I'm converting to radians, I need a pi on top. So it's pi over 180, right? It shouldn't be like, oh my God, which one is which? It's kind of obvious. Radians to degrees, you need the pi's to cancel, so the pi has to be on the bottom. Degrees to radians, you need the pi on top, so the pi has to be on top. And so all you do on the calculator is you just do 4 times 180, and then you divide that by 3, and you get that this is 240 degrees. And then 3 pi over 2. Right? The pi's cancel. And then 3 times 180 divided by 2, this should give you 270 degrees. Okay, and so I know, Susella, you got a little late. All we're doing here is when you measure distance, you measure stuff like you could measure things in inches or centimeters. You could measure things in kilometers or miles. So now we're just learning that we could measure angles in degrees or something else called radians. So all this is saying is, remember how we were doing that unit circle last week? Remember how this was 45 degrees? This is both, you could say this is 45 degrees, or you could say that this is pi over 4 radians. In higher math, they tend to use the radians more, and that's why we're introducing that right now. I know for some of you, this might be the last time you ever see radians, but if you are going on to trig, you will be seeing radians more. Now, the last concept, this is actually going to be really, really quick, is remember how last week we created a unit circle and we had all of these angles, right? Let's talk more about these angles that are formed, right? So in trig, we put all of our angles on the coordinate grid, okay? And forget about the top. We're gonna skip the top. You're actually it's gonna become visual learner. In trig, whenever we draw our angles, so remember in geometry, we used to say that this is 45 degrees. You could also say that this is 45 degrees. This is 45 degrees. In trig, we don't put our angles wherever we want, okay? In trig, our angles always have to start right here. This initial side that I just circled, all of the angles that you draw in trig have to start there. Whoops. So look at this bottom left. You cannot make an angle in trig that looks like that because this is not here, right? The second thing that you need to do in trig when you draw an angle is the vertex always has to be at the center, at 0, 0. So this angle down here is not appropriate because this point is not at 0, 0. So in trig, all of our angles start at 0, 0, and the first side is always here. And then the other side just tells you what type of angle you have, right? This would be something like, maybe this would be like 50 degrees. If your angle was here, it would be something like 130, right? Depends on where the other arrow points. Okay. Now, the last thing about trig angles is in geometry, right? We said this was 45 and we said this was 45. Okay. However, in trig, we talk about rotations of angles. So positive angles are going counterclockwise. So you see the arrow here? That's the way we rotate if it's positive. Because remember that this was 0, 90, 180, 270 when we did the unit circle. So that's why it goes positive if we go this way. Now it goes negative if we rotate clockwise. Okay? So if we go clockwise, like the way a clock goes, that is a negative angle. Okay, so now you're just gonna learn how to draw angles in trig, and that will be the last thing we do. It's fairly straightforward once you get the idea of it. So the homework is gonna ask you to draw what's called a rotation diagram. So here, it does not say rotation diagram, but I'm gonna be drawing rotation diagrams. So we wanna draw a 45-degree angle. I'm sure a lot of you already know what that is, but remember, on our unit circle, we went like this. We went by 90 degrees. So if I want to draw a 45-degree angle, remember that this is, you always have to draw your first ray at the center and it goes to the right. And since, where is 45 degrees located here? Well, it's halfway between 0 and 90. Okay, so that's it. The only thing is they ask you to draw a rotation diagram. So since it's positive, you need to show me that you went that way. That's a rotation diagram. So now what is negative 45 degrees? Well, going positive is going this way. So going negative would mean to go the opposite direction, 45 degrees. Okay. So once again, I always start going this way. But if I go negative 45, you see that you actually rotate the other direction. Okay, so let's do this again, 120 degrees. So remember this is 0, 90, 180, 270, and 360. So 0 and 360 are at the same place, right? So where is 120? Well, once again, you always start here. 120 is between 90 and 180, and it's closer to 90. It's not that close to 180. So it's going to look something like this, right? It's just 30 degrees more than 90. Now, and then we rotated it this way because it's positive, so it goes counterclockwise. Now, negative 120, how does that work? Well, think of it this way. If you're confused about where it should go, think of it this way. If you're going positive this way, does that make sense to everyone? Because if you're going positive 90 this way, then going negative 90 would be right here, right? Negative 180, negative 270, if we're going clockwise. So negative 120 would be somewhere between 90 and 180, closer to the 90. And since it's negative, we rotated clockwise. Okay. So E and F, any questions so far on how this works? So this time we have a 300-degree angle, and so this is 0. And so where is 300 here? Well, it's after 270. It's like 30 degrees after 270, so it's somewhere here. And then the rotation starts from here, and it goes all the way here. The rotation, when you draw the rotation arrow, the tail should always start here with this ray. And then it's going to go all the way to the other ray. And so this is why angles more than 180 make sense in trig, because in trig, the angles are about the rotation. In geometry, the angles were just about the measure in between the rays. So you couldn't do angles over 180. That doesn't make sense in geometry. But in trig, you can be over 180 because now we talk about the rotation, and you can rotate. You can even go beyond 360. We're not going to go over that in class, but you can rotate it more than once and go way beyond 360. So negative 300, how does that look like? Well, remember, if this is 0 and we go backwards, right? So what does negative 300 look like? Well, it always starts with that here. And then it's just a little bit past 270. And then so if I go this way, and that's how it's supposed to go. Okay. Now G and H. Okay, so we're good with that. Now G and H, look what happens. We have radians. Like, how am I going to do this? Well, we just learned how to convert from radians to degrees. Remember, you multiply by 180 over pi. So if I have pi over 2 and I multiply it by 180 over pi, the pi's cancel. And 180 divided by 2, this is 90 degrees. Oh, that's pretty simple. You know that 90 degrees is this angle here. That's all. And so letter H is negative pi over 2, so this is just negative 90. And so, you know, negative 90 is this angle right there with the angle, with the arrow pointing that way. Okay, so do the bottom 4 on your own, and then we'll be done. Okay, so 210, remember you start here, and then 210 is like 30 degrees more than 180, so it'd be somewhere right there. Would look like that. Then negative 210, if this is 0, negative 90, negative 180, negative 270. Okay. So if I go negative 210, then it's just going to be 30 degrees more than 180, right? Because it's between 180 and 270. But the direction you moved was this way. And then 11 pi over 6. So once again, what you're going to do here is you are going to convert this to degrees. The pi's cancel. And so now I just have 11 times 180 divided by pi. Divided by 6. And you get 330 degrees. And so if I was going to do that, I know 330 would be right here. Okay. You don't have to, you know, when you do this on the homework, you don't have to write 0, 90, 180, 270. That's just a way for helping you so you know where it falls between, right? So see, like if you didn't know where 330 belongs to, you know 270 is down here. You know 360 is the full amount, right? So 330 would be close to 360. And then so if I go backwards, I know that negative 330 means I went all the way around almost on the negative direction, 330 degrees. Okay, so that's it. There are a couple of you that like Noelia, Paulina, Suseli, Tony. If you do want to make up that Unit 8 test, right, check your email. It's on Wednesday. The video and the study guide is all there. Everyone else, you're good. Once again, the last class is on Wednesday. We'll be going over the study guide for the quiz. So yes, if you are Unit 6, we passed a long time ago, Paulina. Unit 8 is Wednesday. Unit 6 was last Tuesday. So yeah, so the rest of you, if you want to take it on Wednesday, you can. I mean, like Suseli, you can take it if you want, but I think with that, I think once I update your grade, you probably will be passing. So it's up to you if you want to take it, you don't have to. So I'll try to do that today so you know what your grade is. But if you are going to take the test on Wednesday, those 4 of you, Noelia, Paulina, Suseli, and Tony. Study that video. It has to be, the test has to be taken on a Zoom session on camera. Yeah, that's about it. And so this is the last concept you're learning this year.